X, you can put any X, like a 5, 3, 4, 3, 3, 3, 2, 3, 1, 3, 0, 3. X, you can plug any real number in. Y always 3. Function value always 3. So the range is just one number. It's 3. This is the domain and the range. This for constant function. Like if I say f of x equal 1, the graph is goes through 1, this horizontal line. If I say f of x equals 0, then the graph is goes through 0, which is the x-axis. If I say f of x equal -2, then the graph is goes through -2, horizontal line goes through -2. Then next one, 7, 8, question 9. Question 9, g of x equal to 3 over x minus 3. I changed the number. And this is a rational function. H of x equal to x minus 3. This is a linear function. Find the following. So this is the operations of functions, including divisions. So function A, like this one. Question 9, example. Given g of x equals 3 over x minus 3 and h of x equal to x minus 3. And A, find out h of 2a. H of 2a is just 2a plug into the x, into this x. 2 times 2a minus 3. So it's 4a minus 3. That's A. And B, and A, find g of f. Find out g of fa. G of fa, you plug this 5a. G of 5a, plug this 5a into this x. So get 3, 5a minus 3. This put it in. Another one, find out g of 3. G of 3, you put this 3 into g function. So you got 3 minus 3, and you got 3 over 0. 3 over 0 is undefined. We cannot divide it by 0. There's no answer, undefined. G of 3. Another one, find out g of 0. Find out g of 0. G of 0 is this 0 put in x. Get 3 over 0 minus 3. So the 3 over -3 got -1. Another one, find out h of 0. H of 0. H of 0 is put in h function in x. H function. So it's 2 times 0 minus 3. So it's 0 minus 3 got -3. H of 0. And find out g of 2b. Find g of 2b. G of 2b is this 2b is put in g function in x. So it's 3 over 2b minus 3. Put this 2b in x. So it's 3 over 2b minus 3. The next. And find the domain of g function and the domain of h function. So B, domain of g function. Domain, g function is 3 over x minus 3. So what is x? You can put it in in x, have function value. Is all the real numbers except what? 3, because 3 will make denominator equal 0. Divided is undefined. So no function value when x equals 3. So it's all the real numbers except 3. It's r minus set 3. And find out the domain of h. domain of h function. H function is a linear function. H of x equal to x minus 3. So you can put any real number in x, always have function values. So it's R, all the real numbers, R. Then C is a question example 9C. Find out the function g over h of x and the domain of the functions. So find out g over h of x. This means the two function divided, g of x over h of x, divide. Now example here, g of x is this, 3 over x minus 3. H is 2x minus 3. Now you divide it. So divided is equals. Now 2x minus 3 is put in fraction is 2x minus 3 over 1. So the two fraction you divide is 3 over x minus 3. This division change to multiplication. The second fraction reciprocal 1 over 2x minus 3. So then multiply 3 times 1 is 3. Denominator multiply x minus 3, 2x minus 3. This is g over h of x. And ask you what is the domain of this function of g over h function. So you let this denominator equal 0. Let this denominator equal 0. X minus 3 times 2x minus 3 equals 0. Then you got x minus 3 equals 0 or 2x minus 3 equals 0. Solve for the x equals 3 or x equals 3 over 2. So the domain of this, domain of g over h is all the real numbers. G over h function is this function, denominator cannot be 0. The two number make denominator equal 0. So it's all the real numbers except the two numbers 3 and the 3 over 2. That's the domain of except the two number. That's the domain of g over h. Then next one, C, another example. Find out g times h of function. G times h of x. Multiplication. This means g of x times h of x. Time together. So it's the two functions you time together. Now g of x is this one, 3 over x minus 3 times h function is this one, 2x minus 3. You times together, you got as a 3, 2x minus 3 over x minus 3. This is the multiplication function, g times h of x. And find out the domain of this function. Domain is you cannot make denominator equal 0. So you let denominator equal 0. Solve for the x equals 3. So the domain is all the real numbers except 3. All the real numbers except 3. That's then question 10. Question 10, it's solve the literal equation. 10 example, like this, L equals m over n, m minus n, and solve for n. Solve for n. So this one, you times both sides by m minus n. This also times by m minus n. M minus n cancel. So that is L times m minus n should be equal m times n. And solve for n. So this term have n. This one you distribute it in. Get ln minus ln equals mn. This term have n. This term have m. So make the term with n on one side. Make this on this side. Make this move over. Change the sign. So get m ln minus move over mn. And then this term move to the other side, minus change to plus ln. Then that's two terms have n, you can factor out. So get m factor out, get l minus n, that's distributive property, equal ln. You can check it, ln, check it, mn. Then divided by l minus n, both sides, l minus n cancel. That's solve for m. Get m equals ln over l minus n. Only m on one side. The other side has no m. That's solve for m. Another one, for example, another question 10 example, like p equals rs over q plus r. Solve for r. This one. Solve for r. Also, you times q plus r. So then you become p times q plus r equal rs. You can see here, this term have r. This one distributed in. Get pq plus pr equal rs. And this term have r. This term have r. And this term has a pq, no r. So we make this minus pr both sides. Or just move over, change the sign. So get pr equals rs minus pr. The two terms have r. Common factor, you can factor out. So you got pq equals r, factor out s minus p. Factor out, you can check it, rs minus rp. Then solve for r, so divided by s minus p, both sides. S minus p cancel. So you got r equal pq over s minus p. That's, you can see only r on left side. On right side has no r. That's solve for r. Next question is example. Question 10. Example. Solve for z. This y equals w plus x z over z plus w for z. Solve for z. Also you do y times this equal dividend divided by divisor equal quotient. So quotient times divisor equal dividend. So y times z plus w equals w plus xz. Then remove the parentheses, distributive in. So yz plus yw equals w plus xz. Now solve for z. So this term has z, this term has z. And the two term no z. So make the z term on one side. I move this on one side. The two term on one side and the two term on the other side. So move over, change the sign. Got yz minus xz equal w. This term move over, plus change to minus yw. So since the two terms have a common factor z, you can factor out. Got y minus x equal w minus yw. Now then you divide it by y minus x. Cancel and solve for z. So z equals w minus yw over y minus x. Solve for z. Only z on one side. The other side has no z. That's solve for the literal formula. Solve for the literal equations. That's question 10. Question 11. the number of this is variation problems. The formula is here. Y varies directly with x. Put the equation is y equal y k times x. K is constant. That's direct variation. Inverse variation, y varies inversely with x, is y equal k over x. Y varies directly as x. Don't put with, as x. As x. Y varies inversely as x. So it's inversely is y equal k over x. K is constant. K is constant. Directly means k is constant. When x increase, y also increase. That's positively variation. Directly variation. When x increase, k is constant. Tying together, y also increase. When x is decrease, y also decrease. That's direct variation. And the inverse variation is when k is constant. When x increased, then k is constant, you divide it, then y will become smaller, will be decreased. When x decreased, becomes smaller, then y will be increased, become larger. That's inverse variation. Y and x are inverse variation. So for this example, if here the number of workers n needed to set up for a homecoming varies inversely as the amount of time t allowed for the setup. Inverse variation. So first of all, you write down n, the number of workers, equal k over time t. K is constant. And now given n equals if 30 workers take 20 hours to set up. It takes 30 workers, I changed the number, 30 workers to do the job when there are 20 hours allowed. So I changed to, so n equals 30, t equals 20, and you can get the k, plug it in. N use 30, plug it in. T use 20, plug it in. And 30 times 20, you got 600 is the k. And plug back into here, so you got n equal to, write down, example 11, given is n equal k over t. Given n is 30 and the t is 20 hours, then you do k equals 30 times 20 is 600. Then you plug it into here, you got the n equal 600 over t. 600. So first step, from given condition, you solve for k. Second step, k is constant, so you plug it in. So that is the equation. Then third step, ask you, if given how many workers are needed, n equal what? How many workers are needed? If there are only 25 hours. So if t equal 25, then n equal how much? So you just plug it in. 600, t equal 25, and you plug it in and figure out it's 24 workers. Need 24 workers. So another example. If n is 16 workers and work for 5 hours, so then you put n is 16, put it in 5 hours, put it in t. Time together, k is 80. After you got 80, you plug it in here, so n equal 80 over t. That's the equation. Now ask you, if t equal 8 hours, need how many workers? So you t use 8, plug in, you need 10 workers. And you can see it's inverse variation like this. 30 workers work for 20 hours and 25 hours, you have more hours to work and you need less workers, 24 workers. From 30 workers decrease to 24 workers. If your hours is increased, 20 hours to 25 hours, you work for 25 hours, then you need the same amount of job, same amount of work, you need less workers. So this is inverse. One is 30 decrease to 24 workers. Another one is from 20 hours increase to 25 hours. Inverse variation. This also like 16 workers decrease to 10 workers, but hours from 5 hours increase to 8 hours. This is the workers, and this is hours, and this is T is hours, and ask you how many workers. This is inverse variation. The workers decrease, then hours increase. Hours increase, then you need less workers. Finish the same amount of the job. Like N equal, for example, like this one. 10 workers take 9 hours to finish the job. So you plug it in. 10 and 9, you got K equal 90. And the 90 plug into original, that got N equal 90 over T. That's the equation. Now, then your hours change to 6 hours, decreased, and then become smaller, decreased. Then you need more workers. So 90 T use 6, and you need 15 workers. Your hours, working hours decreased. Then your number of workers increase from 10 to 15, increase. So that's we call inverse variation, a same amount of the job. Question 12 is a direct variation. The surface area of a balloon varies directly as the square of its radius. So we write equation, surface area is S equals K times square of radius, R is radius, R square, so it's R squared, K is constant. So the equation is this, S equal K times R squared. Now, if given the surface area, this is your homework question, I changed number. Surface area is 452.16 centimeters squares, and the radius is 6 centimeters. If given. And what is the area? What is S? S. When the radius is 8 meter. 8 meter. So first of all, from this given condition, and you will do, that's question 12, examples. It's here, surface area equal K times R squared. Now, given condition is S equal 452.16 centimeters squared equals K times R squared. R is 6 squared. 6 squared. So from here, you can solve for K. So it's 452.16 equal K times 6 squared. 6 times 6, 36. Then K equal divided by 36, both sides. 452.16 divided by 36. And you got a K. K equals this, equals 12.56. K equals 12.56. Then you plug it into original equation. So K equals 12.56. You plug it in here. So we get S, that's the first step. From given condition, get K, constant. Second step, you get K constant, plug it into original equation is 12.56 times R squared. So you got this equation. Now, third one, now given if R equal 8, what is S? R equal 8 meter. Now this is a centimeter, 6 centimeter. Now it's 8 equal meter. 1 meter equal 100 centimeter. 1 meter equal 100 centimeter. So this is 6 centimeter. Now go 8 meter. Now what is S? So this equation, R use 8 plug in. So get S equal 12.56 times A squared. So it's 12.56 times 8 times 8 is 64. 8 squared is 8 times 8 is 64. Times together, this times together equals 803.84. But you have to use meter because it's 8 meter. Square is meter squared. Because 8 meters squared, got meter squared. And this is a centimeter, so you got centimeter squared. It's difference. And another question 12. Another example. As an example, first of all, S equals KR squared. From given condition, if given the area is 200 minus 96 centimeters squared and R equal 4 centimeters. So from this given condition, you plug in. This plug in S is 200 minus 0.96 equals K times R. R is 4, plug in. So it's 16. 200.96 equal K times 16. Divided by 16, both sides cancel. So it's K equals 200.96 divided by 16. Then you divide it, you got K is also 12.56. It's the same as this one. It should be same. So then that's the first step. Then K equal 12.56. You plug it into original, and you got the equation S equal K is 12.56 times R squared. That's the second step. The third step asks you if R equal 2 meter, then what is S will be? So then R equal 2 meter, you 2 meter put it in R. So S will be 12.56 times 2 squared. So it's 12.56 times by 4. 2 squared is 4. So you got it's a 50.24. But you have to put the units, because here is R is 2 meter. 2 square. 2 meters square is got meter square. This is centimeter. 4 square. 4 centimeter square is centimeter square. So you got this one.